Hi guys, today is 6.4 simplifying square roots. So watch this video, pause it, stop it, try some examples, go back and watch it again if you need to. This section is usually a little bit confusing. We're going to take 2 days to do it. So we'll get started today. Mrs. Cox will clarify any questions tomorrow, and then you'll practice it again tomorrow. Sorry about the sound on this. I know it's crappy, but it's the best we got. So I want to first point out something different from yesterday. Yesterday was approximating square roots. So when it is approximating square roots, you can go ahead, put it in your calculator, find a number, and use a decimal and put it on your paper. So this can be decimals, and it can be calculated. When you are simplifying square roots, and you're going to have to pay close attention to this, there should be no decimals. And you can use your calculator, but it's not going to be to just hit the square root button, take the square root of 7. It's going to be to break things down. So first thing we're going to do is we're going to add and subtract square roots. I'm just going to go through several examples, and you can take a look, and hopefully you'll see what we got going on. So if I asked you to do this problem here, 5x plus 4x, answer that quickly. You can pause if you need to. Hopefully you tell me that that equals 9x. Or if I asked you to do 2y minus 7y, hopefully you tell me that that is negative 5y. Same idea with square roots. If I ask you to do 5 square root of 2 plus 4 square root of 2, first of all, these have to be like terms. It has to be a square root of 2 and a square root of 2. It cannot be same as you could not combine an x and a y. You could not combine a square root of 2 and a square root of 3. And just like up here, you don't change the x, you don't do anything to it, you don't add it or square it. You just leave it the same. So same thing here, this would just be 9 square root of 2. Or over here, if I asked you to do 2 square root of 3 minus 7 square root of 3, as long as they are like terms, they have a common radical there, you can just, 2 minus 7 is negative 5 square root of 3. Okay? So, I'm going to give you 3 to try. Pause the video, try them quick, and I'll give you the answers. Square root of 5 plus square root of 5. 6 square root of 10 plus 4 square root of 10. And 2 square root of 7 minus square root of 7. So pause quick, try these, and then come back to the answers. Okay, so just like if these were x's, if there's nothing out front, we can put an imaginary 1 there. We can put a 1 in front of anything. So this would be 2 square root of 5. These are like terms, so 6 plus 4 is 10, and it just stays a square root of 10. Put an imaginary 1 here. 2 minus 1 is 1, and we have a square root of 7. Okay? So, that is the idea there. Now, here's the part where it usually gets a little bit confusing. So, next part, we are going to break square roots down. So before we ever start, I want you to put this list on your paper. We're going to list all the perfect squares. So if you have memorized them, you're going to be better off. So perfect squares are going to be 1 and 4 and 9 and 16, 25, 36, 49, and I would put these in your notes and make sure you have them. 64, 81, 100, 121, 144, and we'll stop right there. Okay, these are the numbers that are going to help us. So what we're going to try to do is we're going to try to break numbers down into perfect squares. So for example, if I gave you the number 12, if I asked you to take the square root of 12, we are going to try to figure out what perfect square is in 12 that we can take out. So I'm going to go over here to this list, and here's my advice to you. Get as close to 12 as you possibly can. So the closest number to 12 I can get is 9. And does 9 go into 12? We all know that it does not. So then I'm going to go up the list because I want to find all the biggest numbers. So the next number, I know 4 goes into 12. So if I were to break this down, I can call this 4 times 3, because 4 times 3 is the square root of 12, so I can break it down like this. Now, we didn't do anything, we didn't change anything, they're still in the square roots, we just rewrote it. And this is my advice to you, is always leave it in the square roots the first time around. Now we're going to go back and take the square root of the things that we can. What is the square root of 4? The square root of 4 is 2. Is there a square root of 3? There isn't, so we're just going to mush it up against the 2 and we're done. Okay, let's try the square root of 50. So again, these numbers over here are the only numbers that help us. We're trying to take perfect squares out. So I could call this 5 times 10, but that doesn't help me because 5's not a perfect square and 10's not a perfect square. So I want to pick something off of this list over here. So I'm going to get as close to 50 as I can, which is right here. And I'm going to work my way up the list so I find the biggest number. 49 obviously doesn't go into 50 evenly. 36 doesn't go into 50 evenly, but 25 does. This would be 25 times 2. And now, the first step, like I said, don't take anything out of the square root, don't try to lose anything or get rid of anything, just rewrite it. Now go back, and what is the square root of 25? Square root of 25 is 5. Can't do anything with the 2, so it's a 5 square root of 2. Okay? So I want you to try these 3 on your paper, pause it, and then I'll come back and I'll give you the answers. So square root of 24, square root of 45, and the square root of 98. Okay, so square root of 24, if I start over here, 16, I'm going to get as close as I can. 16 doesn't go into it, 9 doesn't go into it, 4 does. This is going to be 4 times 6. Now the square root of 4 is 2, and there is no square root of 6, and there's nothing that goes into it here. Over here, I'm going to start as close as I can. 36 doesn't go in, 25 doesn't, 16 doesn't, but 9 does. This is 9 times 5. Square root of 9 is 3. Can't do anything with 5. 98. I'm going to start right here. 81. 81 does not go in. 64 does not. 49 does. This is 49 times 2. Square root of 49 is 7. And I still have the square root of 2. Okay? So next thing we need to look at is if you have something that is a quotient. So if I give you something like this, square root of 7 over square root of 9. Actually, let me give you something like this first. Square root of 16 over 36. Now, on your last quiz, what you really did is I told you just take the square root of the top, take the square root of the bottom, and you're done. So the square root of the top would be 4, square root of the bottom would be 6, and we could reduce that fraction. That's what the rule tells us. The rule tells us we can just break this up. I can break up the top, I can break up the bottom, and I can do them separately. Now, if I try to take the square root of 7, is there anything that goes into 7, anything I can take out or break down? There's not. So the top is just going to stay square root of 7. But if I look at the bottom, what is the square root of 9? Square root of 9 is just 3. So that's how we're going to break down the fraction. So let me have you try these 3 right here. 35 over 36. 13 over 4. And 5 over b squared. Pause it, try those, and come back. Okay, so if I break this down into 35 over 36, square root of the bottom is just a plain old 6. Now, the square root of the top, you are going to have to look, because there are going to be times that you can break that down. But if I go up to my last list, is there anything that goes into 35? 25 doesn't, 16 doesn't, 9 doesn't, 4 doesn't. There's nothing. I could do 7 times 5, but neither one of those are perfect squares, so it doesn't help me. So I'm just going to leave it as 35. This one here, I can't do anything with the 13. The bottom is just 2. Can't do anything with the 5. Now you know this. What happens to a square and a square root? They undo each other. So the opposite of b squared, square root of that is just a plain old b. Okay? One more example I need to show you, and then I'll look through quick and see if there's anything else. So we have this problem here, and we have the square root of 5 times the square root of 10 times the square root of 2. How do you find the volume of something? You do length times width times height. So we multiply all these together. So if I can break things down into this, I can also build it up. So first you're going to build this up. So 5 times 10 is 50. 50 times 2 is 100. And then we're going to try to break it down. What is the square root of 100? It's just a plain old 10. Okay? Let me see if there's anything else I need to tell you about. There's a couple in your homework that look like this. Something like the square root of 3 over 5 plus 2 over 5. Now, what do you need to add or subtract fractions? You need common denominators, right? And these are both 5. So if we put the bottom together, the bottom can be plain old 5. Can I put a square root of 3 and a 2 together? Are they like terms? Does this have a square root of 3 with it? This would be like you trying to put x and 2 together. Can I do that? Can't, so I'm just going to write it out as square root of 3 plus 2. Okay? There's only one more I really want to show you, and I guess I didn't leave myself another screen, so I'll do that over here. If I give you something like this, 3 square root of 5 minus square root of 45. Are those two like terms? They're not, so I can't combine them, but hopefully this looks a little bit familiar. On the last page we broke that problem down. We broke it down into square root of 9 times the square root of 5, right? So I just rewrote that as square root of 9 times the square root of 5. And then I took the square root of 9 and I got 3 square root of 5. So now I have 3 square root of 5 minus 3 square root of 5. Are those like terms? They are. I would get 0. I would get 0 square root of 5, but what's 0 times anything? It's just a plain old 0. So there might be some problems in your homework that when you look at them, they don't have common denominator, or not, sorry, they don't have like terms. But you have to look at them for a minute, because if you can still break that number down into anything, you might be able to make like terms and you might be able to make it work. Okay? So give your homework a try, talk to the people around you, compare your answers, ask questions. And tomorrow Mrs. Cox will be back. She'll clear up any questions that you have, and you'll spend another day on this, and hopefully we'll be good to go. So have a good weekend. Oh, not a weekend, it's only going to be Thursday. So have a good week, and I'll see you Monday.